All right, let's dive into something truly wild. What if I told you the rules that govern the weird, fuzzy world of quantum particles are the exact same rules that shape your own thoughts? So let's just start with this question right here. What could an electron possibly have in common with a thought? One is this tiny, almost imaginary speck of quantum weirdness, and the other is, well, you thinking. They seem like they're from totally different realities, right? But what if they aren't? Well, that's the radical idea we're going to unpack today. The theory goes that they aren't just like each other, they're literally born from the same fundamental rules of reality. Yeah, it's a huge claim, I know. So let's dig in and see how on Earth these pieces are supposed to fit together. Okay, first up, Schrödinger's recipe for reality. We're starting in the quantum world with an equation you've probably heard of, but we're going to look at it in a totally new way. And hey, don't worry, no crazy math, I promise. The key thing to get about Schrödinger's equation is that it doesn't tell you where something is. Nope. It describes what's called a wave function, which is really just a fancy way of saying a wave of possibilities. It's like a cloud of all the places a particle could be at any given moment. It's a recipe for pure potential. And this is where quantum mechanics gets really, really weird. So before you look, that electron is literally just a fuzzy cloud of maybes. But the second you observe it, boom, that wave of potential just collapses. It picks one spot and becomes a single concrete thing. The potential becomes real. Now, hang on to that idea, the collapse, because it is absolutely crucial for what's coming next. All right, let's jump from the quantum world into the universe inside our own heads. We're talking about the brain's inner ocean. To get this, we've got to think about the brain a little differently. So there's this thing called the Brain Kinematics Model, or BKM for short. And it basically says, forget thinking about the brain as a computer. It's not just wires. Instead, picture the cortex, the wrinkly part on the outside, as this dynamic, flowing landscape, a mental manifold. And check this out. On this landscape, your thoughts aren't just sitting there. They're actual waves of neural activity that travel across it, kind of like ripples in a pond. They call these strain flows. These are the literal waves of your consciousness. But here's the thing. This mental landscape isn't smooth. It's been carved and shaped by your whole life. You've got these deep valleys, which are your established memories, the memory potentials. Then there are these powerful emotional wells, like deep pits that have this strong gravitational pull on your thoughts. And when you're focused on a goal, you create these channels, or task gradients, that guide your mental energy, kind of like a riverbed. Okay, so we've got the quantum world with its collapsing possibilities on one hand, and the brain's world of flowing neural waves on the other. Now it's time for the main event, connecting two worlds. This slide right here is the absolute heart of the whole idea. Let's walk through it. That quantum wave function, the cloud of what could be. That's just like the constant buzz of potential thoughts in your brain, the cortical activation. And the stable energy states in an atom, well, that's a perfect parallel for our stable brainwave frequencies, like the calm alpha waves or the focused gamma waves. But the biggest one, the real kicker, is the last one. The active measurement in physics has a direct analog in the brain, attention. They're seen as the same fundamental act. So think about what that means. In both of these worlds, a measurement is what collapses all that potential into one single reality. Just like a physicist looking at an electron forces it to choose a spot, your attention takes that ocean of potential brain activity and forces it to crystallize into one single conscious thought. Your focus, it is the measurement. It's what collapses the wave function of your mind. And believe it or not, the parallels go even deeper than that. The argument is that both systems, the quantum world and the mind, are actually governed by the same universal rules. They call these rules strain marks. The best way to think about them is like universal tipping points. Like the exact temperature that water has to hit to freeze into ice. They're these fundamental thresholds where a bunch of chaos suddenly snaps into an ordered pattern. And it doesn't matter if that pattern is a stable atom or a stable memory. And look how specific these parallels get. In physics, you've got the ultimate speed limit, right? The speed of light. Well, the brain has its own, the speed a nerve impulse can travel. Physics has a minimum possible unit of action, Planck's constant. The brain has its own minimum unit, the all-or-nothing firing of a neuron, the action potential. And even the specific stable energy levels of an atom seem to perfectly mirror our stable brainwave bands, like alpha and gamma. It's kind of uncanny.
Okay, so what's the big picture here? What does it all mean if we start looking at the brain this way? It gives us a whole new map for thought.
This leads to a really profound idea, captured in this quote. Schrödinger's equation is more than a quantum formula. It is a general description of continuity. So what if that equation was never just about quantum particles? What if it's actually a universal blueprint for how order emerges from chaos, anywhere in the universe?
The takeaway here is, well, it's huge. It suggests that your thought process, the very act of consciousness emerging, isn't some special biological magic trick. It's the process of order emerging from a sea of chaotic potential, following the exact same rules that shape atoms. Your mind might just be the universe doing what it naturally does. And that leaves us with one last kind of spooky question to chew on. If thoughts are just probabilities, what or who chooses the outcome? I mean, in physics, it's still a deep mystery what actually causes that collapse. In our heads, we just call it attention. But if your thoughts start as a wave of maybes, what part of you is doing the choosing? Who is the observer of your own mind?